Our next speaker is Natalia, and she's with Material Center Leoben, MCL, and her talk is entitled iRODS Use Case, ALPmat, a platform for collaborative AI-driven advanced materials design.
Well, thank you. It's very nice to present what we have been developing during the last years at Material Center Leoben. We have been implementing a platform that is called ALPmat. Oops. I can switch to the next slide. Oh, no. So ALPmat stands for Active Learning Platform for Accelerated Materials Design, and it offers end-to-end services for covering all the stages of a data lifecycle, from the creation to the disposal. And it also provides some services for data analytics, everything following the first principles. And the idea or the overall goal is to provide a single-stop solution for AI-driven materials development. So this is a few words about the architecture of the platform. So it's completely modular from the bottom at the level of the hardware to the software level. All our services are deployed in containerized and deployed in a Kubernetes cluster. We, of course, use iRODS as our data management system behind. We use distributed storage based on Ceph technology, and we have a backup technology based on Kasten. And everything about the reliability and the automation is implemented with Argo CD. So in terms of data management, that is kind of like the most important or the most interesting aspects for this community. We have two kind of services. One that is based on Meta-Linux, but I think so this we will just kind of renew it. We don't know what is going to happen in this regard, but the idea is to provide our scientists a way of administrating their data and annotate their scientific data with some useful information that later on can be easier to reuse the data and to also find the data. And then the second data management service that we provide is combines iRODS and ArangoDB. So the idea here is to provide a tailored data model that includes semantics in the data management. This is very useful because, well, we have very complex scientific workflows, and our scientists really need to annotate all the provenance of how different data has been created and what are the links of the different data. So to give you a bit of like a feeling of how complex the process can be. So imagine that you as a scientist would like to optimize the materials, the mechanical properties of a given sample, a given material, and everything starts at the sample characterization level. And behind of this, just the sample preparation of the system combines many different kind of stages that has a lot of metadata, and we need to keep record of all this information. So we provide a complete infrastructure that enables our scientists to store all this data in a very easy way, and that can afterwards reuse all this data. So then here was the nice video that now I won't be able to show you, that was showing actually how this works, but actually it provides us a kind of a knowledge graph that enables you really to track all the information of your sample prep or of a given sample and what has happened with this sample. And it was like an electronic lab notebook with semantic representation. So if somebody wants to have a look at the video afterwards, I will be very happy to show you.